Welcome to the first session on inequalities. This is maths session 17. So on inequalities, what do we mean? An inequality, if you remember back, okay, the inequalities were the signs like that, greater than, equal to, less than or equal to, all right? So basically there, everything we have been doing up until now is solving where find x where something is equal to something else. Now we're going to look at things where x is not necessarily equal to, be greater than, less than, etc., right? Now, there's a simple set of rules to follow with these, okay? They really, really are. Step one is we look at them and we say, well, let us, for example, say, over here, okay? Let's take this, 2x minus 4 equals 0. 2x minus 4 equals 0. Let us solve for x, right? So we take the 4 over and we say 2x is equal to 4, and we divide both sides by 2, so x is equal to 2. Can you see that we have one solution? X can only be 2, right? But there's many cases in life where we don't want it necessarily equal to, where we can say, well, I'm happy if it's bigger, but it just can't be less than that, right? You think about it, that's kind of like options, right? Yeah, I'll take it if it's 1.8 meters or above, I can cut it, but I can't take it less than 1.8 meters long, as an example, right? Or I can take them in packets of 12, I can't take them in anything less than a packet of 12. So there's many times when we want something that's not necessarily solving it to be equal to it. So we don't need an exact. Let us take this one, 2x minus 4, and let's say less than 4. Okay? Right, in other words, any value of x, okay, it's okay as long as it solves it when it's less than 4. So what do we do with these? Very simple. Treat it as if it's an equal sign. Ignore the greater than sign first off. So let's pretend it's equal to. So we do exactly the same. 2x less than, the 4 goes over, and it becomes 4 plus 4, which is 8, x less than or equal to 4, right? So, in other words, what we're saying is, any number where x is less than 4. Can x be 4? No. Anything less than 4, right? So, it won't work. If I put 4 in there, I get 8 minus 4. I can't have that, because I must have something less than 4. Okay? Well, let's have a look at this then. All right? Let's take it 2x minus 4, same equation, greater than or equal to 4. Remember, we ignore the sign and we just carry on. 2x greater than or equal to 8, therefore, divide by 2, yep, x is greater than or equal to 4. Now, in the previous one, if you remember, we had that x can be less than 4. Here, greater than, but here's the rub. Have a look at that. That little stripe there means x can be 4. X can be anything greater than 4, of course, right? Then the next step is we have to say, well, okay, how do we represent the answers to these? Before we get to that though, can you remember back to that funny r and the funny z that we had and the natural numbers that we had? Okay, can you remember back to those? Okay, and some of them had a 0 with them. Essentially, what are we doing there? All right, what we are doing is we are defining what x can be. For example, okay, if you are doing it, let's say in bottles of water, and each bottle of water is a liter bottle, can you have x of a half a liter? No, because you are limited to 1 liter, 2 liter, 3 liter, 4. You are limited to integers. Or you can have it as much as you like in whatever, in other words, you are all the numbers, right? So it's important that we say what x can be, because if x can't be a half or a third, we have to tell the customer or the client, whoever, sorry, you can't buy it in thirds. You can't go into a shop and buy 2/3 of a loaf of bread, okay? Not that I'm aware anyway, all right? In old days, you used to be able to buy half a loaf of bread. I don't even know if you can do that anymore. But the point is this, is that we need to define x. So we've got to define what x can be, okay? So x, for example, element of R, x an element of, z. All right? That's not going to work, z. This is the integers, right? The integers, and that's the lot. Okay? That's all the numbers, apart from the imaginary numbers, which we're not going to deal with. Okay? In AP Maths, we deal with that. Here, we don't. Right? So let's say, now, how do we tell how do we portray our answer? They're going to ask you to portray your answer on a number line. Right? Just to refresh our memory, a number line, it's got 0 in the middle, 1, 2, 3, minus 1, minus 2, minus 3, etc., etc. Right? And do you remember, how did we indicate if we included a number? It was these were the two brackets, right? Remember those? Or we could have greater than or equal to. That means the number's included, doesn't it? Let's just check. Included, included. How do you represent that? Let me stay with red. If we say we get 3 and it's included, do you remember you had a solid dot? Let's change it and let's have a look at now the green option, where we say, for example, x must be, can you see it's not included? That would then be a hollow dot, right? I know I'm sort of recapping, this was what, grade 9, 8, 9 stuff as well. I know we do it now as well, but we're going to use this now because we've got to put our answers on a number line. So let's do it, okay? Let's say, all right, let's take it, just before we do that, let's just recap. If, for example, let us say, on our number line, okay, let us say we have this, minus 1, minus 1, minus 2, minus 1, 0, 1, 2, 3, say. Now let us say, just change that, it looks a bit like a 2, minus 1. Let us say we get an answer, x must be greater than or equal to minus 2. What do we do first? We say, right, x, look at the sign. We say, right, hollow dot or solid. Equal to means it's going to be a solid dot, right? Means equal to. Bigger than, so I put my little pencil line there. Bigger than minus 2, it means it's that way, correct? So now the next thing is I look, what can x be? If x is an element, right, it means x can be fractions, so it's everything that way. What if they told me x was an element of integers, right? Well, I still have the solid dot because there you go, right? We're just looking at the two scenarios. X must be greater than minus 2 or equal to. So I still have that and I'm still going that way. Okay, can you see what I've done? I first of all said, can I be that number? Yes, I can be equal to, color my dot in on that number. Next, I draw just a faint line showing me which way I'm greater than, which means I'm above. The next thing is I say, what can x be? Oh, hang on. X can only be integers. And how do I indicate it carries on? I put a line up top there like that. That's what I do with that one, right? So that's my integers. Now, I'm at that point now, we say, right, what is the next thing we're going to do? The next thing we're going to do is we're going to look at solving one of these characters, right? Let's just take, let's take this. 2x minus 8 greater than or equal to 0. 2x minus 8 greater than or equal to 0. And they say x element, okay, And we know everything, okay? All our numbers. Okay, let's look. Okay. Let's just treat it as a normal equation first. So 2x must be greater than or equal to, the 8 goes across, divide by 2, x must be greater than or equal to 4. So far, so good. Right, now we say put it on the number line. Draw a number line, naught. Now where do I go? Step 1, I say, right, put in that boundary. My boundary is 4. Right? So I'm starting at 4. And I say, okay, can I be equal to 4? Yes. Therefore, I'm a solid dot. X, can it be bigger or smaller? It must be bigger. So I'm going to go that way, aren't I? Remember, this is my little indicative arrow for myself. This is helping me to work it out. So I put it in, let's say, pencil, all right? Just above, so I know what I'm doing, right? Then I go back to my answer and I say, right, x. The next thing is I say, right, what is it? Is it integers or all numbers? It's everybody, so I put in an arrow like that. Okay? So how do we do these? That's in essence the process we're going to follow. Okay, so we solve the equation as normal. Then we say step 1. Well, let's say step 1, solve as normal. In B, something's going to come in over there in a few moments. Okay. 2, we say, look at the way, okay, when we get to the number line, first of all, look for boundaries. Okay. What is x? X could be 2 different numbers. We could have a situation where 2, 3, minus 1, minus 2, minus 3, 1, 2, 3, minus 1, minus 2, minus 3. We could have a situation, let's plot this. X less than 3, greater than minus 2, okay, or equal to. So what are my boundaries? Minus 2 and 3. So I say, right, I'm there and I'm there. That also gives you an indication of how long to make your number line, doesn't it? So you're going to plot those outer boundaries first. Look for the boundaries, okay? Then we say, right, decide on a solid or hollow dot. Solid is greater than, equal to, less than, equal, greater than or less than. Remember? So here I say, right, my minus 2, so there's my first one, and that one I make solid. This one is hollow because there's no equal to. X cannot be 3. It can be minus 2. Then I say, my next step, 3. I say, okay, look at the way the sign is pointing. That one is pointing that way. That one is that way, isn't it? Right? X is greater than, so, or just go to the boundaries. X here must be bigger than, which means my private sign is this one, right? Let me just remove those. I'll put it in my green, pretend it's a pencil. I'll say, right, this way, X must be less than you. This way, X must be bigger than you, okay? Then I say, right, in other words, the next step is to say, now in this one I haven't said, have I? Okay. Let's check. I have said x, okay, element of, I wasn't. I was just basically messing around with it. But let's say they say, all right, x, an element of integers. Then what do? I put in like so, right? Solid dots at each one of those integers. We're going to do an example now of another one. So then I say, which way is my sign pointing for step 3? All right. And I say, in other words, I get an indication. Is it this way, that way, or that way? Step 4. Okay. I say, look at the element x, element of. Look at this. That tells you if it's going to be that way or if it's going to be that way. Right? The integers means I'm going to have that. The real numbers means I'm going to have that way. Okay? So then basically what do? We join up. All right? You're going to see now. I'm going to do this one here. 2x minus 8 less than equal to 0. 2x minus 8 less than 0. Step 1, treat as normal. Okay? Take the 8 over, 2x, 8, x, 4. Right? So x less than 4. Okay? Now, let's have a look, and they say x is an element of integers. All right? So, we say, right, we've done that, we've found x. Look at the boundaries. 2, let's call it limits. It's 4. So I'm going to not draw my number line up 1, 2, 3, 4. 3, 2, 1. Okay, like that. And now, that was my limits, okay? Then I check at my limits, hollow or solid. Put it over here. Hollow or solid, right? In this case, it's less than, which means what? Which means it's a hollow dot. So I put a hollow there, all right? Now I take my little pencil and I say, okay, in this case, x must be that way. Okay, so that was for check direction of arrows. Number 5 is check, or, and I know you do get natural numbers as well. All right, then we check that. So in this case, what did we have? We had x less than 4. X is an element of integers. Can it be 3? Yep, it can. So that's a solid, solid, solid. And no, I am not going to continue like this, okay? So I then say, right, for to indicate all the integers from now on, I put a little arrow up like that. You may not put an arrow like this, right? Let's say we had that. You can't do that because that one indicates all numbers, doesn't it? Right? So you can see what we've got here. We've got a specific set of rules that we're going to follow for this. Okay? So just to recap, first of all, we look at our inequalities and we take it as a normal equation, right? Working out what x can be or what x can't be. Right? So we work out x greater than, less than, greater than, equal to, less than, equal to. Okay? We work that out first. Treat it as normal initially. Okay? Then when you get to your x answer, right, then we say, right, we draw the number line, we look where x lies. The reason is there's going to be 2 when we come to some of the other equations. We look where x lies, then what do? We say, okay, I put a little dot with him and a little dot there, just so those are my limits. Then we look and say, right, now, can x be equal to that number or not? Is there an equal to sign there or not? If there's an equal to sign, go to it and make it a solid dot. All right? Then we go to the other one and check, can x be equal to or not? If it can't be, make a hollow dot. Then look at the direction of the arrows. On the one side, x must be greater than or less than. Show a little pencil arrow, bigger than or smaller than. Go to the other side and say, which way is my arrow? X bigger than or x less than? Okay? Then, finally, you can look and say, right, is x a natural number? Okay, is it a real number or is it an integer? And then fill them in accordingly between the dots. It's as simple as that. Okay? In the next session, I've got a couple of examples that I want to do on these here, all right, before we get into trigonometry. We're going to do a few of these, but essentially this part at this stage is actually quite a simple section, okay? So next time you come back, it'll also be quite a short one, I think. We'll do a couple of these examples and then we'll move on. And we'll start with trigonometry, okay, which is, yeah, that's basically, there's 3 parts of maths, well, in my book anyway. There's algebra, there's geometry, there's trigonometry, right? Pretty much a lot of the rest is subsets of that if you think about it. But yes, we'll be back and we'll carry on with that. I'll see you in the next session to finish off the inequalities. Cheers.